Okay, well, if not, that's fine. We'll move on to the review for yesterday's problem of the day. Let's see, yesterday's would have been the 30th. Do I have that? Okay. So up on screen, you can see yesterday's problem of the day says a projectile is launched straight upwards with an initial speed of 35 meters per second. And we want to know how long it's going to stay in the air, right? So how long does it stay in the air for? And we can assume, the hint says, if you can assume that if it's moving 35 meters per second upwards when you launch it, it's also going to be moving 35 meters per second when it lands, except downwards. Let me make sure I got this here. Okay. Great. So what do we have then for the givens from yesterday's problem?
Initial speed.
Yeah, we got the initial speed, right? So our VYI. Make sure we can see it's okay. Yeah, and what's that initial speed?
It's 35 ms.
Yeah, great. 35 meters per second. What other givens do we have?
We're looking for the time. That's the next part.
Yeah, exactly. Good. So that's for the unknown, right? We're looking for how long it's in the air, the delta T. That's our unknown. Perfect. We got a couple more givens we can figure out. We know this is something being launched into the air, right? So that means it is in free fall.
Wouldn't the acceleration be like the downward acceleration be like 35 meters per second or no?
Not the acceleration, no. If something's in free fall, we always know what the acceleration is, right? How quickly its speed is changing. And that's to do with the Earth's gravitational field, right?
Oh, wouldn't that be final? Final.
Yeah, your final velocity, right? We do know that as well. So what did you say the final velocity is going to be?
35 meters per second.
Yeah, at least that's pretty close. There's one thing wrong with that, right? We know at the beginning it's going 35 meters per second upwards, and at the end though it's going 35 meters per second downwards. So how do I need to take that into account when I write my givens down? How do we differentiate between upwards and downwards with our velocities? You guys know this.
We have to make one negative 35.
Yeah, we have to make one negative, right? If downwards is negative, that means the final velocity is negative 35, right? So at the beginning, it's moving 35 meters per second upwards, so that's positive here. But when you get to the end of the problem, it's moving 35 meters per second downwards, so that's why we have to put negative for our final velocity. That's good, Jose. And one more, you guys know what the acceleration has to be, right? For anything in free fall on Earth, we can assume we're on Earth. What's the acceleration?
It's gonna be negative 9.8.
Yeah, perfect. It's negative 9.8, right? Always in free fall. If something's falling on Earth, its acceleration is negative 9.8 meters per second per second. Okay, good. So we've got our three givens. We've got our unknown. We just need to pick which big four equation is going to help us here. Anybody tell me that? Which of the big four has these four symbols?
Second one?
Yeah, you're right. It is going to be the second one. So I'll put down VYF equals VYI plus acceleration times time, right? That's our second big four. That's got our four symbols in it. So we do have to do some rearranging today, right? If we want to get time by itself, it looks like we'll need to take two steps to get this rearranged. Remember, the first thing we want to do is we want to get the piece of the equation or the term of the equation that has our unknown in it by itself, right? So we want to get the AY times delta T piece by itself. So to do that, we need to get rid of the VYI piece, and that's being added on to this term. So what should I do as my first step to get rid of the VYI?
Subtract on both sides.
Yeah, right. I would subtract, right? It's since the VYI is being added on to what I'm looking for, I would subtract it to kind of undo the addition. Right. So if I subtract VYI on that side, it goes away. I have to do it on this side as well. So I get final velocity minus initial velocity equals acceleration times time. And I think everybody should be able to do the last step now. The last thing I need is to make sure the time is by itself. So what's the one more step I need to do to make that happen?
Subtract AY.
Close. I do need to get rid of the AY, but I don't want to subtract it because the AY is being multiplied by the delta T.
Divide it.
Divide it, right? I want exactly, yeah. Divide it. That's going to undo the multiplication, right? So if I divide by AY, it cancels out on this side. And I have to do it on that side as well. So the equation I end up with is time equals final velocity minus initial velocity over acceleration. And here's so a lot of people, if you hadn't, a lot of people end up with 0 here because if you forget that VYF is negative, you end up doing 35 minus 35, and that's 0. But when we plug our numbers in, we have to remember that our VYF was negative 35. And then we subtract our VYI, which is positive 35, before we divide by negative 9.8 meter per second squared. And negative 35 minus 35 is not 0, right? That's going to be, well, what I get when I plug it in, negative 35 minus 35, and then I can divide by negative 9.8. And I get, oh wait, I gotta be careful, I have to put parentheses. So I do negative 35 minus 35 in parentheses because that whole thing is divided by negative 9.8. And there we go, I get 7.14 as my time. All right, and I get seconds because I've got meters per second divided by meters per second squared. So the seconds cancels out with one of those seconds and the meters cancels out with the meters, and we're just left with seconds. So 7 seconds for the answer to the problem of the day. That seems okay because if you throw something up with a pretty good speed, 7 seconds before it comes back down seems all right. Questions from you guys on how we got any of the givens or did the rearranging or anything like that from this problem? No? All right. So real quick, I'll show you tomorrow's problem of the day, which is this one. It's a straightforward big 4 one. There's no unit conversions or anything like that. It's just asking, what's the acceleration of an object that speeds up from 8 meters per second to 12 meters per second over a distance of 80 meters? The only hint I want to give you, are we going to need to use 9.8 in this problem? Is the acceleration here going to be negative 9.8 like it's been for the last few days?
No.
No, why not? You're right.
Because it's not going up or down, right? Like.
Yeah, well, it's not going up or down, right? It's not in free fall, right? This object is just accelerating, you know, from 8 to 12 meters per second. It might be a car, it might be something like that, but it doesn't say the object's falling, and it's only when the object's falling that you can assume negative 9.8. All right, so it's asking you for an acceleration, but it probably won't end up being negative 9.8. Questions about today's problem of the day before I let you go and get to work?
No.
All right. Okay, well, that's it then for today. Thank you all for showing up again, and we'll pick right up and finish with chapter 7 tomorrow and go over this problem of the day tomorrow again. So thanks for coming. I hope you have a good day. Stay inside, stay safe, stay healthy.
You too, Mr.
Bye.